Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, and this is my continuing feature on the Math Lovers book. And as I do every Saturday, I'm featuring another biography of a famous mathematician. I'm up to my 23rd of 80 listed chronologically at the end of volume 2, and that one is Gottfried Leibniz, who lived from 1646 to 1716. He was born just 4 years after Isaac Newton. And, like Newton, Leibniz, I think, was a really, really great mathematician. Maybe not quite the caliber of Newton, but, I think Leibniz's main mathematical claim to fame was his independent invention of calculus. He did it about maybe 8 years after Newton, and there's no way he could have known about Newton's independent discovery of calculus because Newton was in England and Newton hadn't come to Germany where Leibniz was living until much later. But anyway, and most people consider Leibniz's version of calculus superior to Newton's, even though both theories really say the same things, and you can make the same calculations with both of them. The thing that really made Leibniz's version superior to Newton's was his notation. I mean, Leibniz used a DDX notation. For instance, if you had a function y of x, you would write its derivative as dy dx, whereas in Newton's notation, we would write y dot or y prime, which is a lot more cumbersome. Um, yeah. So and then the other thing Leibniz did with the notation was he introduced the modern notation for integrals. I think you guys who've studied calculus, y'all know that you have integral sign, which looks kind of like a stylized S, long stretched out S. So for instance, if you look at this formula on the lower right, this is an integral of a function f from a to b, and that's in Leibniz's notation. And Newton did not come up with this notation. Newton used a much more cumbersome notation for integrals. You would write x bar or x with a square around, which isn't very clear, I don't think. So anyway, and another thing Leibniz did with this calculus was he came up with this rule known as Leibniz product rule for computing the derivative of a product of two functions. I don't think Newton did this, but Leibniz did this, and you probably learned this when you were first learning calculus, differential calculus. Pretty basic rule. It says that the derivative of product uv is equal to v du dx plus u dv dx. Just u v times derivative u plus u times derivative v. Anyway, that's Leibniz's product rule. And he also came up with, I think, the fundamental theorem of calculus, which is also known as Leibniz's integral rule, which basically just says that integration is the opposite of differentiation. It says that if you differentiate an integral, you get back your original function. Anyway, so he did that as well. And another thing he did was he came up with a series, infinite series formula for pi, or if you like pi over 4. This formula on the top of this slide is known as Leibniz's formula or Leibniz's series. And it technically gives you pi over 4, but you can just multiply by 4 when you're done to get an estimate of pi. Unfortunately, this is a very slowly converging series. If you wanted to use it to calculate pi to 6 decimal places, you would need, I think, 500,000 terms. I mean, there are shortcuts, and I think Leibniz even knew some shortcuts to make this formula more practical. But I think it was the first known infinite series formula for pi, so I would say that was a very significant development as well. And then he, besides calculus, he did some pioneering work in, um, uh, I guess, functional theory, or this is also used in probability theory. This is nowadays we would call this the binomial theorem. It just says that if you have the nth product of, I guess it's a composition of two functions actually. So if you have f of g to the nth power, then you can write that as a sum of binomials and choose r times f composed with itself n minus r times, and composed with g composed with itself r times. And the binomial theorem looks very similar to this. That's in probability theory. This is in functional theory. So they're kind of similar formulas. Anyway, Leibniz came up with that. And another thing that Leibniz did, which I think was really remarkable, was he came up with an amazing mechanical calculator. And, a few weeks ago I talked about Blaise Pascal, and Pascal came up with an adding machine, which was also called a Pascaline. But Leibniz did better. Leibniz came up with this thing was called a reckoner. I forget what kind of reckoner, but it's also just known as Leibniz's calculator. And here's a picture of it. And not only could Leibniz's calculator allow you to add and subtract numbers with up to 16 digits, it would also allow you to multiply and divide with one operation. With Pascal's, you have to do multiple operation. You can only do multiplication by repeated addition or division by repeated subtraction. But with Leibniz's calculator, you could do them with one stroke. Pretty amazing. And you could also use it, if you use it multiple times, you can use it to estimate square roots and cube roots and I think nth roots and maybe even arbitrary roots of polynomials. I'm not sure about this, but I know you can use it at least for square roots. So pretty remarkable calculating device, I'd say. And this was about over 200 years before the invention of computers. So pretty amazing that we had mechanical devices that could do this. Um, and what else did he do? He was also a philosopher. And I haven't studied Leibniz's philosophy. He had a philosophy of mind involving things called monads. I never studied this philosophy. Uh, I don't know. I sort of took a glance at this earlier when I was making this slide, and it looks a little hokey to me. I don't know. Um, but I guess he talks about different levels of mind and what they can do. And one problem with his philosophy, I think another thing he believed, he uh, uh, was called a extreme optimist, and he believed in his optimism. It was kind of a doctrine of his. He said that we live in the best of all possible worlds. I don't know why he thought this. Pretty crazy idea in my mind. I mean, in other words, though the universe couldn't possibly be any better than it is, and even every world you can imagine wouldn't be as good as the one we're living in. I don't know what kind of world he was living in. He must have been pretty privileged, but I don't think most people in the world would agree with us because I know we've all suffered tremendously. Most people throughout their whole lives, and it's very easy for me to imagine better worlds than the one we live in. And one philosopher who really ridiculed him about this was Voltaire, very famous 18th century French philosopher Voltaire. He wrote a novel called Candide, which is a classic novel. I read this when I was in college, and the whole point of the novel was he ridicules Leibniz's optimistic philosophy. I mean, just all this shit happens in this book. There is a philosopher in this book who I guess is supposed to be Leibniz. His name is Pangloss, and he preaches to one of his students named Candide that we live in the best of all possible worlds. And throughout the book, just all these horrible things happen to Candide, but he's still convinced almost to the very end that the Pangloss was right, and Pangloss doesn't even question his belief till the very end of the book himself. Um, great book. But anyway, I guess that's pretty much all I have to say about Leibniz. Anyway, thank you for watching. Long live math, and I'll see you guys next time. Bye.